MALVINA. So today I'm going to introduce you our group member. First is myself, the second is ELDRED EMIL Victor, next is Finite and Julius, and next will be Syed Muhammad ADIB bin Muhammad YUSNUAR, and our last member is NELVIN Kau Chi King. So first I'm going to present is the introduction. So ice hockey is a high-paced, physically demanding sport that requires high level of skill and endurance from the players. To stay on top of their game, ice hockey players are in need of reliable high-performance equipment that enhance their game skills. Next, one key piece of equipment used by the player is the ice hockey stick. It is the stick that you use to hit the puck to move it around the ring during gameplay. And lastly is that goals are scored in a game by hitting the puck into the opposing team nets. So a stick handle for an ice hockey stick having a longitudinal central axis and upper end and a lower end, the lower end being situated adjacent to the blade of the stick. Next, at various times of ice hockey stick have been made having shaft of solid wood, laminated wood, fiberglass reinforced polymer coated wood, fiberglass reinforced polymers, aluminum, titanium, and carbon fiber reinforced polymers. Similarly, at various times, hockey sticks that have been commonly made of different material, including wood and carbon fiber reinforced polymer. Current conventional sticks are one-piece stick having both a shaft and blade made of a carbon fiber reinforced polymer, the shaft typically being hollow.
My name is Syed Muhammad Adib, and I will explain to you about the project background. Ice hockey stick made up of long slender shaft with a flat extension at one end called the blade are approximately 150 until 200 cm length. The standard from National Hockey League are 160 cm long. The strict measurement can differ greatly since they are typically designed to accommodate the size and preference of a specific player. Project, we choose carbon fibers or carbon fibers are between 5 to 10 micrometer in diameter and mainly made up of carbon atoms, like high rigidity, high tensile strength, low weight, high chemical resistance, high temperature tolerance, and low thermal expansion. Carbon fibers have many advantages so far. Thus, we select carbon fiber because using increased amount of carbon fiber make the stick stronger and the user is able to hit the ball harder. Using more Kevlar allow greater control of the ball due to increased impact or absorption. The objective in this project, which is to perform a design process for ice hockey stick. Secondly, to identify the design load and stress analysis using FES software for ice hockey stick. Lastly, to select suitable materials to meet requirement for the ice hockey stick. Project or limitation in this project is performing the design process using SolidWorks software only. Secondly, identification of the stress analysis and design load and stress analysis and design load using FES software for ice hockey stick. Lastly, selection of the most durable and high quality ice hockey stick such as carbon composite materials are designed for maximum impact strength and responsiveness and hybrid flex profile with carbon composite and fiberglass construction, which is inserted as a strategically placed reinforcement.
Hi, my name is Fernandez and Julius TUNGKIONG. I'm gonna to present the methodology. We proceed to the flowchart. First is we start, then the task given we repeat, then we search the product and design and sketching. Then we go to the technical drawing, then assemble the part, and enter the APA simulation. If APA simulation fail, we're gonna to enter it again, and we end the process of the project. Okay, this is our project. That is ice hockey stick. This is the exploded view. There is three part, that is sharp, blade, and top cap. Finite element analysis, or FEA, is a computerized tool for predicting how a product responds to a real-world forces, vibration, heat, flow, fluid, and other physical effects in it. Analysis of finite element determine whether a product is going to crack, wear out, or work the way it was planned. FEA function by breaking down a particular object into a vast number of finite components, such as a small cube. Mathematical equations help predict each element behavior to model the action of the physical object. A program then sum up all the individual behavior.
My name is EMIL and I am going to present on discussion. Okay, at first our project model are having difficulties in static simulation because the material for carbon fiber that provided in SolidWorks are not valid for simulation. This is maybe due to its material properties and maybe due to the absence value of Poisson ratio. At first, we tried to find the value on internet, but somehow it seems hard to find the reliable source. Then we try using wood material that is balsa. It is a success at first, but the material cannot withstand 200 Newton of force and our model is hollow. So the result for analysis is failed. Then we try to find it on YouTube. As you can see in this slide, this is the material of carbon fiber that used in bicycle carbon frame. So we just assume that the material is the same as hockey stick. Actually, hockey stick is a combination of composite material, but it is hard to find each material properties. So we just proceed with carbon fiber that used in bicycle frame. This is our hockey stick material properties. As you can see, the mass is 0.733 gram, and then the volume is 0.000407 meters cube, and then the surface area is 0.266 meter square. And then this is our material properties that is taken from the YouTube. Fixture and load location. As you can see from the left side of this picture, you can see that the player are holding their shaft on specific location and the ball will struck on the blade. So in order to simulate this situation, we need to put fixed geometry on specific location on the shaft. So we need to use a split line to separate the rest of the shaft with the place where the player holding. And then for the blade, we also use split line to separate the rest of the blade and where the ball will struck on the blade. We are using 200 Newton of force. Why are we using 200 Newton of force? Because usually the ball will struck on the blade at 200 Newton as we search on internet. So as you can see, for the stress, the bond stress, the maximum value is 437.078 megapascal, and then the yield strength is 2.550.0, and then for the strength, the maximum value is 0.002, and then for U rest is 158 and 672 millimeter. And then for the factor of safety, the maximum value is on the top, where the maximum is 249003463671808.0, and then the minimum value is 5.834 on the blade. This is where we simulate our hockey stick by 1000 Newton of force. As you can see that from the stress value, we can see that the maximum is 1874.439 megapascal, and the yield strength is 2.5500.000, and then the strength is maximum is 0.011, and then the maximum value for displacement is 628.773 millimeter, and then the factor of safety is at 1040428.892.160.0. As you can see that usually on the stress, the maximum value is on the shaft where the player holding the stick.
Hi, my name is NELVIN. So I'm going to conclude for our project conclusion. So as the conclusion, we can see that the titanium alloy is the best material for us using in the hockey stick. And because the titanium alloy is provide better durability and strength compared to previous material that is used for the ice hockey stick, and the titanium alloy is very light and is more powerful during using to hit the ball. And this project is allow us as a student to conduct and keep an analysis on material that is better for the project. And this subject also enable us to understand more on the SolidWorks software and using FEA analysis. This project also indicated help us to brainstorm more on project management and flow of the project. So that's all from our group. Thank you.